it would be infeasible for searchers to cache all the piggy banks and know exactly which validator their bundle is going to get sent to and tip that exact piggy bank, right? So the idea was, let's have some misdirection there. So every slot a validator, you'll see at the top of the block when it's a Jito validator, the very first transaction is always this change tip receiver. So it's basically saying, of these 8 accounts, I'm going to be able to withdraw the funds from this account since I'm a leader.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on MEV.io. And Composable. Execute any intent on any chain, coming soon to Mantis.app. That's MANTIS.APP. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%. GM everyone, my name's Tagachi, the host of Scraping Bits. Today, another co-founder of Jito, Seg. How's it going?
Yo, what's up?
Just for the people that aren't familiar with Solana, aren't familiar with you, who are you and what do you do?
Yeah, I'm Seg, or Zano. I'm building MEV infra at Jito. The goal is to essentially make the chain have better execution and UX for users and price appropriately block space and then redistribute the money we make from the block space auctions to the rest of the network. The rest of the network being validators, stakers.
Got you. And how did you actually get into this? What was the backstory? Where did you start and transition into crypto if you did, or just started in crypto? What's the whole lore behind you?
Yeah. So the lore here is that I started speculating on crypto and like tokens I got listed on Binance in 2017. I was still in college. That was like sort of like the cypherpunk in me that just loved Bitcoin, but also the other side of me that just got a thrill out of seeing number go up. So I kind of fed that bug. I never really got into the engineering or like understanding what's happening under the hood till DeFi summer 2020. That's when it was like, okay, wow, you can actually build these complicated systems on this thing. And so that's when I took the leap of faith, quit my job as a normal software engineer in industry and started working in crypto.
Working in crypto and leaving your job, did you have runway or you just made like a giant leap and was like, I'm taking the risk?
It wasn't like too much of a risk. So I started working at this company called Parsec.finance. So I had a job lined up. It wasn't like I was jobless for a while. It was more like, leave like your cozy big tech job at Amazon, a bunch of like stocks on the table, take a pay cut, all that. But really, I'd thrive better in like startup environments. It was easy. It was a no-brainer for me. It was just more about timing and like understanding how things work for me to be confident to be able to work in this space. So at Parsec, we were doing a lot of data indexing, just looking at Ethereum data and other EVM chains and throwing them into a database and then displaying them on pretty charts for people to trade based off of. We started getting into Solana a bit and I was like, holy shit, this is complicated. So from there, I dug a little bit into Solana, started using it, and it was just kind of mind-blowing how fast things were. All at the same time, I was doing, I guess, what I considered MEV on Phantom.
Oh, nice. Phantom guy. I was Phantom as well.
Yeah, Phantom was like the hipster chain, right? Everybody was on BSC getting rugged. Yeah, Phantom was fun. So I was like, I was in all those lucrative farms and just writing things there.
Hell yeah.
So you can relate.
Did you ever hear of SolSwap?
I did.
That was me. I made that.
Oh, no way.
Yeah.
Okay, cool. Yeah, I was doing all there's like this space one that was really fun. It was just a bunch of space characters. You just farm things, right? Like,
yeah, it's like a farm chain, really. Airdrop NFTs, the good old days. Send me back to way back when.
Yeah.
Okay, so you messed around with MEV on Phantom.
Doing a bit there, and then I started digging into Solana a little bit. I wanted to write a bot on Solana. It was just like Solana versus like programming on Solana, just the programming model and like understanding how the smart contracts work are just way different than EVM-based contracts.
Yeah.
So I started looking around to see if I could work with anyone. And I got introduced to Buffalo on Twitter, who just so happened to be trying to work on some MEV strategies, I believe, on Solana. We chatted for a bit online, shared some code with each other, and ultimately decided not to start like an MEV prop shop, but instead to take a bet on Solana becoming the leading DeFi chain going forward. And with that means there's going to be a lot of value to capture on the MEV side.
What made you think that Solana was going to become the main chain instead of ETH? Because ETH has the first mover advantage. So what made you the decision?
I don't know. It seemed kind of obvious at the time because of how fast it was, right? Like the UX was so much better. I mean, you've used ETH when gas is really high?
Yeah.
Yeah, it's like not sustainable, right? And then the L2 thesis was like, to me, is just kind of kicking the can down the road and then you figure it out later. So I don't know, it seemed kind of obvious to me, just like build on this thing that's the most performant and try to maximize performance at the L1 before you even think about more complicated architectures with L2s and whatnot.
Well, so you did you took a bet with Lucas instead of doing MEV bots. And then how did you get to the idea of building this infrastructure? And was Flashbots out at the time as well?
Yeah, Flashbots was out at the time. So definitely took some inspiration there. The core idea was we want to maximize trader profits so that we can maximize what we redistribute to everyone. And in order to do that, I believe there's like a balance between and how much profit you can maximize. So like, let me give you an example. Like, let's say I say, hey, you have a year, and after a year, you can like collect a bunch of transactions over the course of a year. And after a year, you're going to submit me the most profitable 100 combination of transactions. You're probably going to be able to submit me much more profitable batch than if I was like, all right, you have 1 minute to collect transactions and do that. But then it's like, all right, well, that's not obviously like, that's an exaggerated example. So 13 seconds is too long for block times for like global financial infra to run. And continuous time I think is too fast to be able to have like a smooth UX. So what we do is we run 200 millisecond time auctions.
Why did you choose 200 milliseconds?
Well, Solana runs at 400 milliseconds. So we figured let's do 2 a slot.
Just half it. That was it.
Yeah, just do 2 a slot. Why not? And that number is pretty tunable, so we can bump it down to like 100 milliseconds if we want.
It's interesting because like Lucas was mentioning, you'd get like maybe 20,000 bundles, right? And let's say a bundle can range from 1 to let's say free instructions or free transactions. Sorry, and each one of them has X amount of instructions. 20,000 times 3, right? That's 60,000 transactions you have to simulate in 200 milliseconds. How do you really do that? I guess my intuition is you just skip a few, right? Because having all of those, like imagine cycling through 60,000 transactions, making sure they don't conflict with each other. Maybe they do conflict with each other. How does that all work?
Yeah, I mean that's like the crux of the problem for us is like we need to simulate everything. At least the way things are built right now is like we simulate everything to figure out what's the most profitable stuff we can submit to the validator. But yeah, you're right in the sense that when the auction does tick, it's not feasible to, for example, sometimes we have like a couple 100,000 bundles sitting in memory. So it's not feasible to run those over the network, send them to this other server that runs simulation on them. There's a lot of overhead there. So what we do is we pick like the top end, have these bundles sorted by tick, and then we just select the top end, and end can be whatever.
Okay, so you select like a predetermined amount by sorting them in order of tip. Okay. I assume you like clone the bank and then go one by one from basically, the top in terms of tips. That makes sense.
Yeah. So the idea behind the auction is I'm going to assume that viewers or listeners are familiar with Solana's account model. Is that a safe assumption?
Yeah.
Okay. So yeah, Solana's account model unlocks parallelization, right? Bundles are touching a bunch of different accounts. So the idea is that we select the top bundles and then we submit them for parallel auctions based on their account rights.
Oh, okay. Parallel account. Okay, so if bundle A and bundle B are interacting with the same account, you're submitting them both at the same time and seeing if they conflict at all?
Yeah, so those two would be we call it a job. So that would be one job because they have account contention. And they may or may not be submitted to the validator together. So like, let's use an example. Let's say an NFT mint comes up, right? So 1,000 of us try to mint it. Let's say there's 1,000 available. We should all be able to get our bundles through for that mint.
Right. But what if my NFT, what if it's the final one and now you have two conflicting bundles? One of them is minting. I mean, they're both minting, but then they're both interacting with the same account.
Right.
How do you drop any of them, or would you still submit both of them? Because if one of them's going to fail, what do you do with the one that's failing? So conflicting bundles, I guess.
Right. So in that case, we would simulate them, and then our simulation results would deem that they could not go together, and it would just basically choose the highest paying one out of the two.
Okay, that makes sense. You just drop
But in the case, right. But in the case where they could go together, then our simulation result would be send them back to us and say, hey, send them in this order to the validator.
When you send them off, right? Let's say you send that one off, then someone else, another bundle, maybe like, I don't know, like another 20 milliseconds comes by and asks the mint. How would you simulate that? Is each simulation just for that bundle and you're resetting that state? Or are you coming back and like keeping that in the cache? So when something else comes and conflicts, you have that remaining in the cache, that state.
Yeah, so if I'm understanding correctly, you're saying once we submit the bundles to the validator, that we assume if it's processed, right?
Yeah, like do you just reset the state for another bundle, or are you persisting the state after submitting it for like new bundles coming in?
So not explicitly. The idea is that our simulators are receiving data fast. So let's say we submit those bundles and they get executed like within the next 10 milliseconds by the validator. In theory, our simulators should have that data and replay that into their bank. And then we should, on the next simulation, be up to date. So the name of the game is just keeping your simulators as up to date as possible.
Yeah, wouldn't that be like a lot of I/O overhead though? If you're sending it off and then it's coming back and pinging you like, okay, this is good, and then you keep your state. Wouldn't you just assume that it's already executed?
I mean, I/O is we're definitely I/O heavy. I think Solana in general is I/O heavy. The hard thing about like assuming that it processed is, okay, what if it didn't process? And that happens a lot.
Okay, interesting. Yeah, because what I'm thinking is when a validator gets, a validator it's an interesting situation because you have transactions, so standalone transactions plus your bundles, and now they're conflicting and they have to build some kind of sorting algorithm to deal with this. Do you have any ideas how people would do that?
Which part?
The conflicting bundles and transactions. I assume you'll just prioritize the highest fee, but maybe the standalone transaction by itself is not valuable, but everything depending on that succeeding is actually more valuable than the bundle succeeding and everything below that, like a dependency tree. Just some faults.
Yeah, I mean, like this scheduling stuff gets really complicated.
If I'm a validator, right? So you've sent the bundle to my validator, and I'm getting inflow of transactions and your bundles, so standalone transactions and your bundles. How do I deal with conflicting states that are competing with each other? Because let's say the bundle actually has higher tip than the single transaction, but the single transaction succeeding means all these other transactions coming after it are actually way more valuable than when the bundle is landed and everything else below that. Because the bundle landing and all the transactions below that are actually less valuable as a sum than the standalone transaction. Does that make sense?
Yeah, that makes sense. Yeah, I mean, that is a hard problem, right? And how to deal with that, at least how we currently deal with that, is you have like the normal transactions that you're describing. They try to grab locks on the accounts they're touching, and then you have the bundles also trying to grab the same locks. So there's not any, they're just greedily trying to grab these locks. So if the normal transaction happens to grab the lock before the bundle, then the normal transaction gets the priority of execution before the bundle.
Do you think there's any kind of, I guess, naive solution for top of head thinking about this? Because if they're competing for locks, just like whatever comes in first, obviously that's very inefficient. Yeah, maybe there's another way.
I mean, maybe throw everything into a heap, sort it, and then do some combinatory simulations on them without taking too much time. It's tough because you're saying that there's a transaction that if it executes, everything that was seemingly like low profit is now like very profitable.
Exactly.
Given that, so you need to like, it sounds like a combinatorially explosive problem.
Yeah, and if the transaction and the bundle are just competing from one address, I wonder if you can just like sim them both at the same time and see, maybe you could build like multiple blocks at once. Maybe that might be a thing.
Right, like build a bunch of blocks in parallel and then like select the most profitable one. That's essentially, like you're running these combinations, right?
Yeah. You're taking, it's like I guess Monte Carlo, except without, I guess you would have to remove the mutex though, right there. I mean, not remove it, but have some kind of like replacement. Because if you have like some Monte Carlo thing and it's taken the most like probability is like, okay, maybe the bundle is always like the better one because it has higher chips, so we'll usually take that. But then you have another one that's like, okay, well, let's take this other small chance because maybe it's actually better in the long run.
So the Monte Carlo is a statistical approach to this.
Yeah, exactly. Yeah, and I think that's where you can do like AI. It might be pretty interesting to do that, but obviously quite advanced if you get.
Yeah, I mean, you could probably like based on the accounts and like the signer you could predict maybe, you know, if someone's constantly sending you highly profitable transactions, then you could probably statistically assume that they are for the most part.
Actually, yeah, that's a good point. Yeah, you could build up like a record of most profitable, I guess, signers. How likely are they to send another profitable transaction after theirs? That's interesting.
Yeah, and then you just groom your data set like after the fact.
Yeah, you prioritize those. That one, you take it into account. Interesting. Okay. So,
and that's probably where our system's going to be heading. You mentioned how many bundles we were getting. So like sometimes we're getting 2,000 a second. Sometimes we're getting flooded with much more. And a lot of these bundles are failing, and they're just they're basically running the experience for the good searchers.
Yeah, because if I'm a searcher and there's no limit to sending as many bundles, I would just spam it until I land, like incrementally increasing tip until I land, basically. And I assume that's what they do, right?
Yeah.
How would you actually deal with spam? I know this was a giant issue with you guys, and even just Solana in general. Like it's just a bad thing to just not spam. There's a higher chance of landing if you spam. So, what do you think are like? What were you seeing actually that these guys were doing? The techniques they were applying and how it was getting through your systems of like continuously adapting.
Yeah. So one thing I've been seeing is, so we have API keys that we have searchers fill out. In the beginning, we would vet them out because there wasn't a lot of volume there. Not a lot of searchers were filling them out. And then as time went on, we started getting like 1,000 requests a day. And then the ops guys on our team just started approving everyone, right? Like it's possible to vet everyone. So what you end up with is a bunch of Sybils. So people with hundreds of API keys just spamming us with bundles. The way we deal with that is my first inclination is to like rate limit people, rate limit by IPs, rate limit by API keys. And then beyond that, like you need some economic back pressure, I think. And rate limiting by IP gives you a little bit of that because IPs aren't completely free.
You could switch your IP though very easily.
Yeah, I mean, there's some like technical effort. Like there's like a small barrier, right? Like it's not completely free though.
Yeah, better than nothing. But I guess going beyond that, how do you disincentivize spamming?
So we have a few ideas internally, but I think it boils generally down to economic back pressure, making it expensive for you to spam.
Right. So maybe
it's like
lowering costs for it.
Yeah. Yeah, exactly. I mean, if you send good bundles, then you're fine and you don't have to pay a price. And if you send bad bundles and a lot of them over a long enough time period, then you're borderline malicious, I think, or just like lazy. So you should pay a price for that.
Or even something like an exponential fee for the amount. Let's say one person, sends a bundle, then another is sending, I don't know, like 100 bundles in a single block. So in a single, like I guess the auction's 200 milliseconds. So 100 and 200 milliseconds. I guess a way to disincentivize that is to exponentially grow a fee within that time, right?
Yeah. So you're suggesting let's just say global fee to keep it simple. So I send you a bunch of bundles. The cost to send a bundle goes up exponentially.
Yeah, because like if you just did linearly, I'm sure they're making enough money to cover that. So if they're in the MEV game, right, and they're actually doing well, I'm sure they're killing it and can cover a linear cost.
Right. Yeah. I mean, like on the surface, I like that approach. I think question arises with like what becomes the experience for like the innocent guy, for example, who's not spamming and is just sending their normal bundle every second.
Yeah, I don't think there would be a fee for the first bundle though. But then I guess an instant way around that is you just send it for a different signer. So
you're saying exponential fee for that person that's sending the bundle?
Yeah, exactly. Yeah, but then they could just get around that with new IP, new signer, like a wallet cycler. So So that's a interesting. I see why it's hard.
Yeah. I mean, I think sibling makes it hard.
I think, are you guys doing like a reputation-based thing like Flashbots?
Not yet. We've started talking about a design for that.
Because it makes sense. If someone's sending a shit ton of bundles, you could give them priority, like a priority queue, basically. Is it a tier 1, tier 3, signer, and they have to build it over time, like a reputation based. I think they did that really well in Flashbots.
Do you know the inner workings of it?
I don't. I just know that, the better you basically just stick with a wallet, and then over time you build up reputation for doing good bundles, and then you get priority over, like, you get placed in a different pool to others, which gives you priority, basically. Yeah, it's pretty. I think it solves it quite well.
Cool. I imagine there has to be some historical decay.
Yeah, that would make sense. Maybe.
Like if you've been dormant for a year,
yeah, it makes sense you drop. Because then imagine just like blasting a ton of wallets and then just letting them chill there. It's kind of
and like the landscape has changed over the course of time, and you just come back and your strategies suck.
It would be like let's say League of Legends, right? For example, if you're going into like platinum and you just stop playing for a year, you're probably not platinum anymore. You can't just like jump right in there and then fuck the whole game up. You're actually bronze, guys. I don't know if that's the lowest anymore. I haven't played in ages. Okay, cool. So how were you dealing with spam bundles before? Or spam transactions, all of that stuff previously?
Yeah, so it's come quite a long way. It's still got a long way to go, but there was just a bunch of bottlenecks, I think, in the code that needed to get fixed to basically handle the spam. So
what kind of bottlenecks?
Just like dumb things with like locks or reallocations happening. So like, let me give you an example. Let's say your system's not being used a lot, so you have some buffer somewhere that you don't expect to get filled to over, let's call it 1,000 items. Now, 6 months down the line, your system starts seeing like millions of items come in per hour or half hour. Now that buffer needs a capacity of like 1 million, for example, to avoid all the so dumb things like that. We're redoing a small part of our auth system. I'll wait till that's ready to share more details and get the announcement. And then you mentioned the reputation system. That's something on the back of our minds too.
Okay, interesting. The one thing I think that everyone is wondering when it comes to receiving transaction inflow is how the fuck do you deal with the ever-growing amount of transactions that are being sent? Like, let's say when Firedancer gets released, it's 1 million transactions per second, I'm pretty sure. So split that in half, that's basically the equivalent of a block time. So you're getting 500,000. And let's say, like, in terms of bundles as well, 500,000 divided by, let's say, 3 maybe. That's like 166,000 bundles. How are you going to scale to handle this kind of stuff? Like, what are the major bottlenecks that you're seeing right now? I guess in terms of benchmarking, like, what is really the biggest, the biggest bottleneck?
Yeah, I think those bench numbers that you're mentioning with Firedancer, I don't know. I imagine it'll be a couple years before like the cluster actually requires that your node be able to handle that much, right? Because if you're basically as fast as the lowest required node requirement for the cluster. But I do think, like, looking forward, that is the right direction, right, to compete against like traditional finance. So there's probably some architectural changes with how we've built things. So generally, when we first started the system, it was a little more over-engineered, and over time we peeled layers back and deleted a lot of code and removed a lot of dependencies that we feel are over-engineered as well. Just kind of getting closer to the metal as we've learned things along the way.
Closer to the metal as in like hardware?
Yeah, like less layers between your code running and the OS. So for example, we were using Kubernetes early on, and we completely got rid of that.
Oh, right. Nice. Good. Are you building this in Rust or like something else?
Yeah, everything's in Rust.
Okay. Is there any plans of going pure assembly? No.
Yeah. No.
Yeah, no plans. Okay.
Maybe like some C code sprinkled, or maybe some stuff that lives close to the edge on the network layer.
On the network layer. Okay. Yeah, I guess at the What do you think is the challenge right now for you guys? You're getting 20,000
or 20,000 bundles every single block. Is it really like an inflow problem, or is it a simulation problem? Sending it off, propagation. What's the hardships here? What do you need to get to the next level, basically?
Yeah, I think the hardest thing for us right now is figuring out how to keep our RPCs, our simulators, following the latest tip of the chain. So basically not having them fall behind. When they fall behind, basically your simulation results are stale.
Right. Yeah, that makes sense. Did you ever modify the runtime at all? Like make your own custom simulation environment?
No, we haven't done that. That might be so we've been doing everything sort of like external to all that, right? Like everything on top of it, like optimizing the block engine and everything around it, but we haven't dug into the runtime yet.
Okay. I actually really like the runtime. That's my background is really in reverse engineering. So I did that on the EVM, and that was really fun. The SVM looks a lot harder.
How would you describe the EVM runtime?
Very simple, very easy to build up. You can smash that in a day if you really wanted to.
Really? Okay.
Solana, I think, is a lot more. It's a lot harder because it's like a registry system.
Right. Versus stack based.
Yeah, from what I see. And it's just, you've got to learn basically assembly of Rust, which isn't as easy as something like Solidity. I think, and there's no, I mean, like if you have a reverse engineering background, like cyber background, then like it should be a breeze, to be honest. But yeah, people in crypto aren't really like that.
Right.
But yeah, if you find someone that with those skills, like it's definitely like a smash and grab for sure.
I mean, we're hiring, so if anyone's listening and has those types of skills, hit us up.
I have those skills. But yeah, no, I think the runtime is like incredibly, to put it simply. I did a podcast with Joe from Anza, and we talked about that. So if you feel that you want to get more into it, definitely listen to that. It's all about the runtime. Runtime V2. Interesting. Yeah, the simulation stuff is it seems to be the biggest hurdle for everyone, including validators. Because if you're getting so many transactions, like I think simulations in general, there must be a lot of heuristics to take to just not need to simulate everything, because you have like the sig verify and checking if something is even true or not. There's a lot of things in a simulation that I think you could actually just not do in general. Or like heuristically, where okay, if it doesn't pass this check, just don't sim it at all. Or if it does pass this, maybe go to something else and then sim, or maybe do a partial sim, or I don't know. I think there's a lot of things instead of doing a full sim.
Right. Yeah, I mean that's a good point. I think my gut right now is I've seen correlation to our nodes running behind. I've seen a correlation with high IO. So I think the simulations, like what's really happening, if I had to guess, is all the account database accesses are slow.
I wonder if you can just like grab all of them and put them locally. Maybe there's like some kind of pattern that you can see where it's like, oh, if the access is this, it's probably accessing all of these. So maybe like hard code them or some shit. I think because like there's a lot of tech debt in Solana in general. There's a shit ton of places you can really optimize hardcore if you know where to look and if you're really just curious in general. I think that's what it comes down to, actually. Are you curious about this? Yes or no?
Yeah, and like, are you curious about this, and do you have a good sense of what metrics to look at? I think.
Yeah. You can be great at something and just not know what to really like look for. Because the Solana code base is giant. It's not big. So you got to really specialize, I think, to begin with, and then generalize, branch out of it. So have you seen, what kind of interesting things have you seen with the people bundling? I know I've heard some stories of someone using one signer for the front run transaction, another signer for the back run transaction, or throwing in a transfer or two to kind of deter or obfuscate the sandwiching. Is there any other techniques that you're seeing now or saw in the past?
Yeah, I think you're talking about like the statistical sandwiching and things like that to get around the system. Yeah. Let me think. I think mostly have been seeing just meme coin sniping. That's like, just listen for a liquidity ad on some meme coin and then snipe the supply.
Oh, okay. Just token sniping then. Okay. Yeah, I think that's pretty common though. Then you reckon?
Yeah, that's pretty common. We had one searcher doing interesting NFT stuff that I don't know if he'd like me to share, but so I'll just leave it at that. It was fun to see that.
How do you actually do like analytics on Solana? Because you can't look at past state, I believe. Maybe you can.
So yeah, I mean you can. It's the whole ledger is replayable starting from Genesis. It's stored in Google. There's a few parties that store it in Google, so you can get it from, I think Solana Foundation has it, and then some of the RPC providers do. We do too.
Oh, so you can make like a custom tool and just have the ledger like module and just run through it if you had like that. I guess that Google thing.
Yeah, exactly. Actually, Buffalo created a tool. I forget the name of it. It was like Snapshot, something with Snapshot in the name of it, but
Real sick.
it's a little tricky because the format of the packets changes over time. So to replay it, you need a specific version of Solana Ledger to replay that specific packet. So that's where things get a little tricky.
Okay, you could just implement every single version then.
Yeah, and just pattern match and figure out which one to call into.
I reckon you could do that. I mean, it'll be
you could do it. Yeah,
big lift, but definitely possible.
you could do it. You just got to do it.
Executing is always the hardest thing.
Yeah,
Actually on Solana, because there's so many transactions.
yeah. Who's building this?
Come on, guys. I want to give this guy a grant. Get it done. Tell me how you actually how you built the system from ground zero to where it is now. Because thinking of the idea of, okay, let's be the flashbots of Solana. How to, tell me, what was it like starting out, expanding, scaling, going through the hurdles, the hardships, and getting to the point where you are now?
Yeah. It's cool to think like we were the flashbots of Solana, and now I've heard people will be like, oh, these people are building the Jito of Sui or whatever chain. So it's cool to hear that. But yeah, I mean, we had an idea of what we're trying to build, right? So working backwards from that, we had like a design of it, and in the beginning, it was a handful of us, so like 3 of us working on it. And Buffalo naturally fell into the validator code. I was mostly in the block engine, and then we had the relayer as well. So in the beginning, it was just code really fast, merge it, ship it, try to get to mainnet as soon as possible. And then when we finally got to mainnet, then it was like, all right, now we have to spread the gospel and get people running the validator, so we get runtime on mainnet.
How did you convince people to actually use your validator?
Yeah, I think after you get, you got to build relationships. These people are human, so I think after you get a few of the strong validators on board, the dominoes start to fall in place, because it's not a hard sell, right? You tell a validator, hey, if you run this piece of software, you're going to make more money, and at the worst case, you're going to break even, or make as much as you would have made running the other client.
Okay, so it's easy. It's an easy sell at that point. Don't even really.
Yeah, I mean, I don't want to take credit away from our ops guys because they're kick-ass, but I think it's just I wouldn't call it easy, but I would say the operation is not easy, but it is an easy sell.
Yeah, I mean, if you make money or you go even, well, easy. It is no brainer at that point. Interesting. Okay.
And then so the system looks completely different now than what it did back then, in terms of just like reliability, performance, all of that. And I don't think that's ever going to stop. A system, like a software system, is kind of like this living, breathing thing that you have to basically take care of like a baby for the rest of your life.
I am curious. I don't know if we talked about this, but how does the normal Solana client prioritize? Oh, I guess the Jito. Sorry. How does the Jito client prioritize bundles over other working threads? Because I think, does it support 1.18 now? The newest update, newest scheduler.
You're asking about the bundle thread in the validator?
Yeah.
Yeah. So there's no prioritization there. So it's just whoever gets the locks for the accounts first gets to execute first.
Right. It's just the same. Okay. What's you?
Yeah. So what we do is, on our side, we try to make it such that bundles have a head start over normal transactions.
Okay.
But it's not really deterministic.
Right. And do you give bundles a head start instead of just letting it first in, first serve kind of deal? I guess it's more incentivized for people just to use your shit then.
Yeah, I mean, the idea is, I personally think we should try to not build a system that incentivizes the latency games.
Right.
So if you're not delaying anything or doing any of that, then it's all about who's the fastest, who can get in the closest locations, and just creates the barrier to entry is a little higher.
Got you. Right. Yeah.
Whereas if you can try to like level the playing field a little bit. So there's this exchange. It's pretty interesting. Their name is IEX. Have you heard of them?
I haven't. No, I don't think so.
So it's a similar idea. So basically, what they do is they have a very long cable running into their computers, and it's like extremely long, and they have it wrapped up. It could have been short, but so they're purposely delaying everything coming in to give everyone a fair advantage. So they're trying to get away from like latency races. They call it a speed bump.
Oh, okay, got you. Yeah, the latency races are just not fun because then you price out everyone just being a bigger corporation. It's just whoever has the most money and infrastructure wins at that point. But this is why I liked Ethereum. I guess Ethereum is also kind of latency. It's like how fast can you do simulations? Again, it's always that problem. And how much can you actually compute and bring in data to send out data for like the bidding auctions? It's always a latency game at the end of the day. If you have better latency than someone else, you can do more things with the same
right.
time.
Right. But if your latency is like 13 seconds versus 400 milliseconds is much different.
It is. Yeah, it's a completely different game, but the concepts still apply and the principles. You have more latency, you can do more, and there's 400 milliseconds. I mean, less latency, sorry. Have you ventured out to any more block space kind of games? I know in Ethereum, there's a lot going on. I know MEV.io, one of the sponsors of the podcast, is doing some cool stuff. You can do like futures as well with block space. Is there any plans to expand this?
Yeah, block space. There's like that ticketing system on Ethereum they're proposing. Is that what you're referring to?
Ticketing?
A ticket to propose the block. That stuff's cool. I mean, so I was talking about L2s earlier. Now we're talking about this. So even if I don't think that something's going to work, I still want it to get built because it just makes everything more robust when you have like different approaches to doing the same thing.
Right. Yeah, exactly. And it's also inspiration. Like once you see it in the wild, you can just remix it. Just kind of what people do with games. They see the good parts of a game and just yoink it and make their own.
Right. Yeah. I like the idea of block space futures, giving validators a way to hedge out, maybe risk. In theory, seems like a cool idea. We don't have any plans to implement anything like that. I would love to see it get built anyways.
Oh, yeah, definitely. I want to see Ethereum and like all blockchains thrive. That's kind of the name of the game we're in. I did actually message you a couple weeks ago, I think. It was about some interesting things I saw in the blocks. It was the top of block when there was bundles were actually just tips. And I was like, why are all the tips happening as the first transaction? Can you explain this for the people that are familiar?
Oh, yeah. You're talking about the change tip receiver we were talking about. Yeah. So, okay, every validator has a piggy bank for MEV each epoch. So that's basically how we keep track of how much a validator made during that epoch. And then when we redistribute all that at the end of the epoch, we take it out of the piggy bank and give it to their stakers. It would be infeasible for searchers to cache all the piggy banks and know exactly which validator their bundle is going to get sent to and tip that exact piggy bank, right? So the idea was, let's have some misdirection there. Basically have 8 accounts that every validator uses. So have 8 accounts that searchers tip, and they can tip any of those 8 accounts. Each time a validator comes online, they basically set the like withdrawal authority of that account to their big piggy bank. So every slot a validator, you'll see at the top of the block when it's a Jito validator, the very first transaction is always this change tip receiver. So it's basically saying, of these 8 accounts, I'm going to be able to withdraw the funds from this account since I'm a leader. And then at the end of their slot, they drain the account into their piggy bank. And then the next leader comes on and sets themselves as the withdrawal authority.
So how do they set themselves? Is this like a public function, or how does it work? Because I asked you this before. It's like, okay, if they're doing a transaction to set themselves, what's stopping me from making a clone transaction and making me the piggy bank?
Yeah, so it's one of the Jito programs. If you look through our repo, we have Jito programs repo. It's called the tip payment program. So they're basically calling the smart contract function change tip receiver to my piggy bank. And the way you prevent like anyone else from basically stealing those funds and setting themselves as the withdrawal authority is you just simply don't allow any transactions that touch that program. No one has any use for that program unless it's the validator running at that slot. So in the Jito-Solana validator client, you'll see that we filter out any transactions that try to touch that program. So they can't make it into the block.
Is that that's through simulation, right?
It's just so you have the ingress part of the validator. The leader receives the transactions and deserializes them. And it just looks like, does this transaction touch this specific program? If it does, just discard it.
Oh, interesting. I wonder...
Are you thinking of ways to break it?
Yeah. I wonder if you can obfuscate the interaction with it so it can't be discarded.
That's the thing with Solana. Like, inherently, you cannot do that because you have to declare the programs and accounts you touch in your transaction.
What if you hard code it in the program?
Well, you still have to declare like that program ID in your transaction. You have to say, I want to basically like the way you invoke a smart contract on Solana is in your transaction, you have a program address that you're declaring. You're saying, hey, load the program that's located at this address. There's some executable code there. And I would like to invoke this function at that address.
Okay, so you're just checking all the instructions that are being hit.
Yeah, we're just looking at what accounts is this touching? Is this touching an account that matches to the Jito tip payment program ID?
I wonder if there is any ways of...
like if you do obfuscate it, then there's no way to load that program to begin with.
Right, that makes sense. I'm sure there are some nuggets if you go deeper into it.
Yeah, let's talk offline.
Because imagine if you do figure out how to do that, and I've heard about the stories of the people locking someone else's program by just spamming transactions. So if you can obfuscate it, you can lock it, and then the validator can't actually withdraw, and it's just stuck there. And then the next validator actually yoinks their money. That'd be quite hilarious. To be honest, I think the days are so early in Solana. I'm sure there is something like that. Just because I don't know anyone that's doing, and like obviously the incentives for actually going low level like that is just so low. So I doubt anyone's actually looking.
Let's say you want to invoke, let's say Drift, right? You want to go run a trade against Drift. So you create a transaction that says, hey, I want to buy a BTC perp, okay? And I want to buy that on Drift. So what your transaction looks like is it has some like random data that gets fed into the Drift trade function, but that same trade function needs the BTC market, and that market is an account. Like everything on Solana is an account. So what you do in your transaction, you say, okay, feed this or lock these accounts so I can use them in this program. And in order for you to invoke the Drift program, you have to say, here's the Drift program ID that I want you to invoke for me. If you don't give the Drift program ID, then the validator the runtime has no way of loading that program.
Yeah, definitely. I think it's a matter of actually just looking at the runtime, like the SVM itself, how it actually executes all of the opcodes. Because, EVM was so easy because someone made a EVM.codes and you understood everything. But I guess
interesting.
You would have to go into actually the code base and understand it all, which is a lot, the gateway is a lot harder to open than going on a website that tells you everything.
Oh, this is cool. I didn't know about this.
Yeah, it's great. A lot of people, including myself, learnt this stuff because of that website. And then the Huff community was a big thing from Zach Williamson. Just sparked like a whole group of people, optimizers, low-level guys. But without something like that resource, I don't see that ever happening at a mass scale or having like this ripple effect like it did on Ethereum, which is fair. It's incredibly complex on Solana relative to Ethereum. Creating your own like emulation environment, it just seems like incredibly difficult on Solana, but you could definitely do it if you really put the effort in. I just want to know your thoughts actually on the future of Solana MEV and where you see this is going, where it's currently going, and let's do short term, like 6 months, 1 year, and then maybe.
Yeah, I guess like the future of MEV and block building. I can speak to that, what I think is going to happen. So I think the goal is to try to maximize value for validators. What that does is it makes it more attractive to validate on Solana because there's more money that you can make other than just like inflation. So I think I see block building I see it becoming more profitable. Like if you, for example, look at the total MEV tips from last week sent through Jito, it was about 54,000 SOL. And that's with like what the market looks like today, right? So I think in the next couple of years, Solana will get more usage, and the idea is that execution will be even more snappy, and hopefully a lot of the congestion issues we've been seeing get solved. a user shouldn't have to really know that they're trading on a blockchain. Like it shouldn't feel that way. They shouldn't know like, oh, this RPC is good, this one's bad, or things like that.
Where do you see like MEV searches coming into play? I feel like this is, I mean, now that the mempool is shut down, at least to my knowledge, I feel like it is back at pre-Flashbots era. I mean, it feels like pre-Flashbots era Solana right now.
I guess it's a different approach to the sort of accelerationist person's approach to this. Is like an accelerationist would say, do everything that is possible, right? And just accelerate to that end state and then try to fix things from there. I think our approach is more like, all right, well, we tried that and we saw a lot of negative things coming out of that. If your users are losing all the money that, they won't be able to buy any, there's no meme coins left to buy for them. Don't have any money left. So instead, like, let's try to build towards a better end state along the way. And I think currently the mempool in the form that it was not its optimal form. There is the possibility that you see reincarnation of it in a completely different form. And that's just me. I'm not speaking on behalf of Jito here. I'm speaking on to like what I think could happen, whether that's like some app launches their own mempool or Jito launches another version of the mempool. I do think like you will have like better mempool spin up.
Interesting. I'm keen to see what the future of MEV and Solana is like in the future. I hope Solana does succeed because it is a very fascinating chain. It's I think a lot more interesting than Ethereum. But man, I'm super glad I got to have a chat with you and learn about simulations and bundles on Solana. I know a lot of people are wondering about this stuff, so I'm very confident people are going to find some value in this. So, Seg, it's been a pleasure, my man. Thank you so much for jumping on the podcast. Appreciate your time, and I'm very excited to see what the future holds. Probably have you on again later down the road.
Thanks, my man. It's fun. Appreciate you.
Of course. And anyone that wants to be hired, just hit him up.
Yes,
hiring. But until then, take care. I'll see you later.